So, how many people here believe semiconductor is the king again? Not.
The rest can leave, actually.
So, let me tell you the history. Semiconductor used to rule the tech world in 80s and 90s. That's why the name Silicon Valley came, actually. All these companies at that time, which are the top semiconductor companies, started at that time. And then came the internet era when people said semiconductor is a commodity. Software is the only game in town. And then last 2 years you have seen the what happened to the stock market. Some of you follow the stock market, if not the technology side, what NVIDIA did to the stock market. So now I believe semiconductor is the king again. And we have two luminaries from the most prominent semiconductor company here with us today, Anand and Jaya, who head Micron and semiconductor. So I hope you know what Micron is into. Micron is one of the top semiconductor companies making memories. Memory is a very important component when it comes to making the systems for the AI world, both DRAM and the flash memory. And AMD, if you follow the stock market, you will know the meteoric rise of AMD over last few years, and some of the cutting edge products coming there in the AI world, because AI is the hottest topic, I think, in town. After sun, I think the hottest thing is AI at this point of time on earth. So, AMD has done a fabulous job there. I think if you want to buy an AI system, AMD is the second choice or only available choice after NVIDIA. So with that, I'll just want to give a little introduction before I hand it over to my esteemed speakers here, that semiconductor design process is a very complex thing. It has many stages, starting from architecture to design to circuit design to layout, and then making files ready for the fabrication. And then fabrication is another process by itself. It's a pretty expensive, and you know about the new fabs that are being set up in India. And Micron is one of them to have set up assembly plant in Gujarat. So I think a round of applause for Micron to have started the fabrication journey for India. So with that, I think I would like to ask our first speaker here to Jaya about, given that we have such a complex design cycle, and you are making chips, AI chips for the world, how much are you using AI for your own design, which is, given the complexity involved, and what are the imperatives for you to use that?
Sure. That's a great question, Sanjeev. So AI, as we all know, has a huge potential. It has a potential to reshape pretty much everything that we do today. And before I talk about AI and its impact on semiconductor design, I'd like to take a look at what's happening in the semiconductor industry today. The chips are becoming pervasive. Pretty much every sector needs automation and chips. While the demand is huge and very aggressive, there are challenges in chip design that have emerged. We no longer get the kind of scaling that we used to get with every new node that we enter. Moore's law, which actually said, every 2 years you can double the transistor count in your design with minimal cost, is no longer holding good. And the customers need chips with the smallest of areas, lowest of powers, highest of performance, while keeping the cost at bay. So these are huge challenges that we are facing in the industry today. And of course, whenever we are challenged, innovation happens. So that's been the case with the semiconductor industry as well. We've had huge, strides of innovation, especially in the architectural side with heterogeneous computing, chiplet architectures, advanced packaging methodologies, and also adaptive computing, and many more. Now, AI has come in as this new evangelist, and it's touching pretty much every aspect of the design. I mean, for those of you who are not familiar with the chip design process, we have various stages. The first starting is, of course, the architecture and the definition in a natural language, but we take that and do the design, description in hardware description languages, which is called the RTL. And then the verification teams verify the pre-silicon design, and then that is implemented into gates. And that's what is actually sent to fabrication. And we also have DFT, design for test, where we introduce test circuits in the design, pre-silicon, so it aids us in silicon testing. While AI has had a huge impact on each of these sectors, it's also something that the design engineers and teams are using heavily for productivity enhancements and optimizations, not just early warning. A lot of mistakes down the line can be avoided at an earlier stage with use of AI. For example, RTL, there could be constructs that are not really conducive for implementation, and those can be flagged much ahead of time and not really wait for the design to get to the implementation phase. And AI has also helped in coming up with the most optimized RTL code, which is sometimes it assists the RTL engineers to come up with several optimizations. Then we come to the next phase, which is the verification. Verification is an extremely labor-intense discipline. You need hundreds of engineers to verify your chip, and designs are extremely complex. That's where we have seen a lot of benefits with engineers learning to debug with AI-assisted tools, and also triaging, effective triaging of the failures, and then anything unique that you don't want to ignore can be flagged. And also, coverage. We write thousands of tests to get the coverage, line coverage for our pre-silicon design. And that has become a lot more easier, and we have cut out a lot of redundancy in the testing. And then comes the implementation. With every process node that we move to and shrinking technology, it is difficult to close timing. The tail becomes much longer with every node change. And this is where AI has come in extremely handy in predicting and placing and routing of the design in a very optimal manner, and also in getting the timing closure much ahead of time. And there are some macro placements that can play a very critical role in your design. So some of these things with AI-assisted methods, we have been able to get great results. So, and then last but not the least comes the test circuits with DFT that we introduce. AI has been able to help us get the most optimized test circuits, which don't take up too much of the area. And also, we package the scan patterns, using AI methods, which in turn, honestly, has saved a lot of tester time, which is a very, very expensive resource in chip design. So overall, I would say, again, this is only the start of using AI in chip design, and I believe we're already seeing a big impact, and the journey should continue, and we should see a lot more optimizations and use case scenarios coming out. Thank you.
Oh, wonderful. So, this is called, you eat your own expression, American expression, you eat your own dog food. You're giving AI to the world, so you use it for your own also. So same thing with you, Anand. When you are designing cutting-edge memories for the most advanced systems of the world, how are you getting it into your design process?
Sure. Good afternoon, everyone. Glad to be here, and thank you for the micro unplug, Sanjeev. Appreciate that. Some context setting, right? And there is a famous American researcher who said that very often advanced technologies tend to be overestimated in the short run and underestimated in the long run, right? It's because our expectation of a technology intersection in our 40-year, 50-year flow is often misguided, right? So at Micron, we fundamentally believe that AI will play a very important role in design flows. And as Jaya rightly pointed out, it's a start, but we're very clear that it's going to be pivotal, useful, and impactful. That's the underlining statement. Three trends are happening in semiconductors. Jaya talked about the scaling challenge. We have the scaling challenge in logic. We have it in memory and storage. What the scaling challenge is doing is we're not able to make chips smaller, faster, better, as we used to do in the past, because physics is coming in the way, the laws of physics are challenging, the silicon gap is a fact of life, there is only so much you can do without getting into molecular level interaction, preventing you from performance enhancements. So all of us are trying different workarounds. In all of these workarounds, one of the workarounds that Micron has is we're trying to stack a lot of memory with an underlying logic in the bottom. We call it a high bandwidth memory. We work with partners like AMD very closely, and those kind of creative stacking approaches they're used in AI, but there is also a big motivation to use AI in the building and fabrication of those devices. So clearly, Moore's law is having an indirect impact of embracing AI much more than in the past. The second thing we're doing, and again, Jaya kind of hinted at it, the typical waterfall development flow that we have in chip development, architecture, specs, and then getting into validation and test towards the end. It is impossible to manage in a very dynamic world like ours. It takes almost 3 years for us to design something and have high quality, high volume ramp of silicon. So historically, the way we would circumvent that delayed process would be to shift left, as we call it, where we try to do a lot more of hardware simulation and software, abstract hardware, and see if we are able to predict the likely outcome. So that's been happening for many years now. But thanks to all the new machine learning techniques, our ability to shift left and abstract has gotten much better. And the intent here is we cannot completely shrink that 3 to 4 year cycle of designing complex chips. The analog chips can be much faster, but we can certainly save a lot of time by ensuring that different machine learning techniques that we have, neural networks, GAN, GNN, all of these are helping us kind of shift left much better. So clearly that is the third part, the challenge in silicon business. I'm making it less and less attractive now, I get it, but keep faith. The challenge in silicon business is we have to start modeling performance of transistors and materials much ahead in advance. So at this time, we have engineers at Micron trying to figure out the parasitic performance, the material selection, the transistor design of what will come up 5 years down the line. And we can't run wafers, we can't run silicon. A lot of the data science and modeling is happening now, and thanks to all the machine learning techniques, that modeling process has gotten a lot of boost. So from a Moore's law scaling challenge to being able to short circuit the design process to being able to model and predict better are the high level areas of intersection of AI in the design world. Just a couple of more comments. The three broad pillars that we look at analysis, we look at optimization, and we look at what I call implementation. Implementation is where we have a very strong need because very often this is a practical challenge that we have faced. I'm sure Jaya might agree with me. In areas like physical design, layout, these are very critical tasks, but it can't keep an engineer interested for a very long time. A lot of these processes are extremely manual, and they haven't changed too much in the last many decades, right? So we almost have an urge to automate these processes even more and have our best people work on higher order problems. So the implementation part is where I find the highest level of impact and ROI, because there is also a practical need to change how we do these things over the next 3 to 5 years. Analysis is very important. Like I talked about, not to make this too technical, but we do what is called a parasitic extraction. There are a lot of small things we do in VLSI design where essentially we're able to visualize what the layout, the routing, the parasitics, the IR drop, all these different things we care about in circuit design. We want to be able to see them much earlier and faster. And thankfully, all of us have enough data with us, with the amount of silicon that we have run in the last many decades. So we kind of, through either reinforcement learning or through new techniques, we ensure that we are able to predict and make a lot of good, useful assessment. So we are beginning to see a lot of good examples. Just before we joined the session, all of us were chatting about there is an automatic pressure from leadership to quantify this in terms of, hey, productivity, impact, ROI. The question that I often get from my leadership team is, okay, if your layout is getting automated, are you using 10% less people on a design corridor or more? And these are the obvious questions being asked. But I think not to play an intellectual game here, apart from productivity gain, we are also seeing better silicon outcomes. So it's also the quality of silicon, not just the number of people deployed. So we have a lot of faith in how AI can help. All areas identified. It's an early days, but work in progress.
Good. So AI is definitely gone beyond the boardroom, and from boardroom down to the design room. I think everybody seems to be now aligned and working towards that. Since it's a design and engineering conference, two things which, in my mind, really test the boundaries of engineering. One of them is the space technology, right? And this aeroplanes and rockets, things that we do for the right reason called rocket science. We really push the boundaries of the science there. And the other one is semiconductor design. It is pushing the boundaries, in a manner never before. The terms that we use here, started with millimeter to micron to nanometers, and, now coming down to angstrom, and which is 10 raised to power minus 10 meters. So imagine in your mind whatever, I don't know how to even quantify it in physical terms. That's the level that we are moving at. And after some time, we'll start tracking where each electron is moving. I think that we are heading in that direction. So that's the complex. So if we don't follow some terms from what these guys are saying, that's okay, because it is really as complex as rocket science or even more. So Jaya, to you, there are, when you do these designs, there are companies, EDA tool companies, which are Synopsys, Cadence, type of companies who are making tools for you to design. How much you rely on them for your automation, AI, and how much are you doing in-house for that?
Sure. So the relationship between EDA companies and design teams is kind of symbiotic. Right? You can't just create tools and optimize them without feedback from the design. And the design engineers are really the ones who know the pain points. They kind of know what is taking longer than they would want to or like to. So they can actually figure out a lot of optimization points and give that as a feedback to the EDA. And that's how, unless the two are married, you really won't see that kind of adaptation into the industry. So I think it's a very important relationship or a partnership, and that's going really well for us. We have partnered with our EDA tool vendors, and they are making a lot of strides using AI, and we are benefiting from that. And we've created a feedback loop with innovation.
Wonderful. So Anand, I'll ask you a slightly different thing on manufacturing. How do you see AI getting into your manufacturing of devices? So maybe in 2 minutes, given that I need to do one more round of questions.
Sure. I think I'll tell you there's a healthy competition between the engineering teams and manufacturing teams in terms of adoption of AI. Engineering is tougher. Manufacturing is also tough, but it's a little more controlled and optically more viable. Because in a manufacturing setup, you look for two things. You want increased yield, you want defect reduction, right? And we have seen, I'll just two examples that come to mind, Sanjeev. We have this concept of what is called a remote operation center. We have all these fabs in different parts of the world, very often managing the line flow of these tools, making sure that you're able to pause a wafer or start a hot lot, or quickly do predictive maintenance on equipment. And back to Jaya's point, just like on the engineering side, we have the EDA relationship. We are having more relationship with our two equipment makers, right? Applied and KLA, Lam, and many more. So there is a symbiotic relationship where we share a lot of data. And we have seen things like remote operations center become a reality now. So what it essentially means is you could be sitting in any part of the world and literally tracking, assessing data, providing predictive analytics, and giving creative interventions for factories across the world. The other one where we're seeing a lot of, it's a very traditional, simple application, but it has a very clear correlation to impact and performance, is video analytics, right? Again, as Sanjeev was pointing out, there are millions of steps involved in the entire silicon flow, in the front end and back end. And very often we have a nice database of imagery of what is good and what is not good, right? And at a very simplistic level, by able to match images, we are able to say, listen, this is not looking good, I'm going to pause and assess if this is going to lead to some unnatural or a wrong outcome. So we are seeing a lot of video imagery analytics, starting off from simple applications of analytics, moving into more advanced application of AI in some cases. And remember, even a half a minute pause in a wafer flow can translate to billions of dollars in terms of either savings or loss. So the importance of these have to be assessed against the kind of ROI they can actually get. So we're seeing higher ROI in manufacturing because it's just more tangible compared to design at this point of time. And I just gave you 2 examples. There are probably many, many more such examples.
Thank you. If you ever get a chance in your life, do visit a manufacturing or a fab, semiconductor fab. You're not allowed to walk in just like that. You have to wear bunny suits or space suit kind of a thing before you go in. So it's not easy to get in, but if now India is going to have it, so fine. If you get a chance, please do. So the last round, Jaya, I mean, semiconductor companies traditionally hire all the electrical engineers who have knowledge of, solid state and, who have studied semiconductors in college or experience around that. Has the hiring pattern changed, and what is that you're finding in your hiring patterns and the supply of that?
No, more than actually the hiring pattern changing, I think AI has become more like a foundational course. I mean, every engineer, it's important to understand the concept of AI and how to really use AI concepts into the work that they do. That is where we have seen a lot of leverage. I mean, you can't really say, yeah, learn AI and come, you can work on chip design. That can't happen. I mean, the chip design knowledge is very important and absolutely essential, but if that can be, married with a knowledge of AI as a foundational course, I think the engineers can do a great job in understanding where AI can help them in the long run.
How about you in your organization?
I think similar, Sanjeev. I think what we're finding is we've been debating at Micron, should knowledge of data science and AI should be centralized versus should it be federal in nature, right? In large companies like to centralize and federate. Okay, center of AI and machine learning research center, right? That won't work in design. And to Jaya's point, we need almost every engineer to be a data science AI citizen. Without sounding ageist, younger engineers are embracing it much better. If I talk to my most amazing circuit designer in the US or in India, they are still questioning the value because they have so much faith in their ability to go and spin silicon. The younger lot seems to be much more open to learning. And once you start seeing results, it's like almost, you have to see some impact coming out of it. You got to be recognized for that, and then the reinforcement learning starts. The loop kind of starts growing wider. So we don't see a lot of people who have both AI expertise and silicon domain expertise. It's challenging to find that fit. So it's a lot of on-the-job training that we have to work on to get people both to embrace and to make the most of it in their work.
So hiring is becoming demanding, right? Look at them. They want electrical engineers who are good at circuit design, logic design, and they know the AI knowledge. So the big bucks don't come easy, of course. So that's the message for everyone here. If you're guiding somebody, tell people to do more electrical engineering, more electronics, and couple that with AI. Would that be the right thing? Would that make a good resume for you? All right, so that's the recommendation or that's the message that you all leave out here with. Smaller the size of the silicon and the technology, higher is the gain, monetary gain out of it. So thank you so much for joining me here today. Wonderful session.
For more content on tech and leadership, subscribe to Nasscom YouTube channel and press the bell icon to never miss an update.